Welcome to YouTube channel Scientific underscore Math. In earlier lectures, we discussed Gauss Elimination Method, MATLAB code for Gauss Elimination Method, Gauss Elimination Method with pivoting, MATLAB code for Gauss Elimination Method with pivoting, Gauss Jordan Elimination Method, MATLAB code for Gauss Jordan Elimination Method, and Gauss Jordan Elimination Method with pivoting. I will provide the link in video description. You can watch all these lectures, and in this video lecture we will write a MATLAB code for Gauss Jordan elimination method with pivoting. Okay, first we use initial command CLC clear all, and here we are using a format that is rational. And for example, we have a given matrix, and that is coefficient matrix A, this one, and the matrix B, and this is okay. So before applying the Gauss Jordan elimination method, first we write the augmented matrix, and next we use a size command uh, for the number of rows and number of columns. Okay, so here we start the pivoting section, and first we use a for loop for j is equal to j is equal to 1 to r minus 1, and this mean for example we have a 4 cross 4 matrix, and this loop will be from 1 to 3. Okay, here r is the number of rows, and here r is equal to 4. Okay, so next we check if the pivot element is 0. For example, this one and this one. For j is equal to 1 1, j is equal to 2, here will be 2 2, and so on. Okay, so if this one is equal to 0, if the pivot element is 0, next we use for loop. If the pivoting is required, search in the row below for a okay, for a non-zero, for a row with non-zero pivot element. And then for example, if this one is equal to 0, then we go for a search the row with a non-zero pivot element that is below this one. Okay, so then this is used to print number of rows, the row, and the pivot element that is 0, and with we are switching the row. Okay, so next here we switching the row with the row that has a 0 pivot element with the row that has a non-zero pivot element. Okay, so then we check AB is equal to K from, and okay, KJ that is non-zero, the row. Okay, if the row that has the pivot element is non-zero, okay, and this one is the row that has a zero pivot element, we switch both these rows, the row that has a zero pivot element and the row that has a non-zero pivot element. Okay, so next we update the row that has a zero pivot element with the row that has a non-zero pivot element. Okay, then break, we use break, and this one, and okay, so this is the pivoting section in which we search the row that has a zero pivot element and the row that has a non-zero pivot element, and then we switch both of these with each other. Okay, next we write a code for the Gauss and Jordan elimination method. So first we use a for loop from 1 to length of b, and this one, and next we write fprintf command, okay, to show this one and this one. Next what is this? And this is the normalization. What is normalization? We divide the pivot row with the pivot element. Here we divide the pivot row with the pivot element, and this will give us a normalized pivot row. Okay, so next we use Gauss Jordan elimination method, in which we eliminate the off diagonal elements. These are the, and this is the diagonal element, and we eliminate all those elements which are off diagonal other than the diagonal elements. We eliminate all these terms. for if I is not equal to j means the elements which are not on diagonal. Okay, so then we use this command to print this one and this one, and this is the Gauss Jordan elimination procedure, and then we use and these commands. Okay, so next we write a command and to show the uh, roots of the unknowns that will be x1, x2 and x3. We run this code in MATLAB. We run this MATLAB code and we will see the results of Gauss Jordan elimination method. Okay, so here we can see that this is our given augmented matrix, and what we can see here the pivot coefficient is 0. So we can see pivot equation 1 has a 0 pivot element, so exchange with row 2. Okay, so here we can see that the row 2 is exchange with row 1, and now we have a non-zero pivot element. Okay, so then and so on, then we apply the Gauss Jordan elimination method to normalize the pivot row, and we also uh, make zeros of diagonal elements. Okay, here we can see that all the off diagonal elements are 0, 0, and this is the solution of our system of linear equations, and the values of the unknowns, and x is equal to 5, 8, and 10. Okay, so thank you so much for watching my video. Please subscribe my channel scientific underscore math for more videos.